So now in previous sums we have already seen that we have to find the value of y at x when the previous or initial conditions were given. But now we'll see one problem where we have to find the initial conditions first and then you have to solve using a regular method. So to find the initial conditions we have to make use of Taylor series. So suppose the example is like y dash equals to y square plus xy. It is given and one initial condition is x equals to 0 will give you y equals to 1, that is y of 0 equals to 1. Then we have to make use of Taylor series and then we have to find values of y of 0.1, then y of 0.2, y of 0.3, and then after this initial conditions you have to find y of 0.4 by Milner's predictor corrector formula. So now let's see how we can compute. So suppose it's given y dash equals to y square plus xy and y of 0 equals to 1, that is x0 equals to 0 and y0 equals to 1. This is the given condition. Now we'll have to make use of Taylor series. So Taylor series is given as y of x equals to y0 plus x minus x0 y0 dash plus x minus x0 square upon 2 factorial y0 double dash plus x minus x0 cube y0 triple dash upon 3 factorial plus up to so on. So we need to calculate first three terms, the rest of the terms we can neglect. Okay, so now we know that x0 equals to 0, so substituting this value we'll get, and y0 equals to 1, so y0 is 1, so 1 plus x y0 dash plus x square upon 2 factorial y0 double dash plus x cube upon 3 factorial y0 triple dash plus up to so on. Okay, so this is a Taylor series expansion at x equals to x0. Now we have to find y0 dash, y0 double dash and y0 triple dash. So for this what we have is this y dash equals to y square plus xy. This is given. So now as we have to find y0 dash, we can substitute y0 dash equals to y0 square plus x into, that is x0 into y0. So this will give you y0 is 1, so it is 1 square is 1 plus x into y, that is x0 into y0 is 0, so this will give you 1. So value of y0 dash is 1. Now we have to find y0 double dash. So for this we have to differentiate this equation first. So y double dash is equal to, so to find this y double dash, now this equation of y is in terms of x. So now to calculate this will become 2 into y into y dash, that's by chain rule. So we have to use this x into y dash plus y into x, derivative of x is 1, so y into derivative of x, that is 1 because we are taking derivative with respect to x, so this will be just y. We need to calculate y naught of double dash, which is equal to, now it will be 2 into y, so this will be 2 into y naught into y naught dash plus x naught into y naught dash plus y naught. So after substituting value of y naught as given 1, so the value for this will be 2 into y naught, which is 1, y naught dash, which is we have calculated as 1, plus x naught is 0, y naught dash is again 1, y naught is 1. So after substituting this we'll get y naught of double dash equals to 2. Similarly we have to calculate now y triple dash. So y triple dash of x will be equal to, now we have to differentiate this. So first we'll differentiate to y into y dash. So this will be 2 constant y into derivative of second, so y double dash, plus 2 into derivative of first, that is y dash, into second one as it is, plus again this x into y double dash, that is x into derivative of second, plus second into derivative of first, so x is 1, so it will be just y dash, plus derivative of y is y dash. If possible, calculate y fourth derivative of y, so that your answer will be more appropriate. So now y fourth derivative of y is equal to, again you have to derivative this, 2 into y into triple dash, plus 2 into y dash into double dash, plus 2 into y dash into double dash, plus 2 into y dash into y double dash, plus x into y triple dash, plus y double dash, plus 2 into y double dash. Now I have not calculated y naught of triple dash, so y naught of triple dash will be equal to, after substituting y as y naught, y double dash as y naught double dash, x equals to x naught, we will get this as 8. And similarly, after substituting this, so y naught of 4 dash will be equal to 22. Now substituting all this value in equation 1, we will get y of x equals to 1 plus x into y naught dash. Y naught dash we have calculated as 1, so it is just x, plus x square upon 2 factorial, as it is y naught or double dash is equal to 2, so this will become into 2, plus x cube upon 3 factorial into y naught of triple dash, so this will be equal to 8, plus y naught of triple dash is 8. So now we have calculated again y 4 dash, so we can write here x raised to 4 upon 4 factorial into y naught of 4 derivative. So now 4 derivative of y naught is equal to 22, so you can write 22 upon 4 factorial into x raised to 4. So now this becomes 1 plus x square, plus 8 upon 3 factorial x cube, plus 22 upon 4 factorial x raised to 4. So now this is the value for y of x. Now we can substitute whatever the conditions are. So y of 0.1, to find y of 0.1 you have to substitute x equals to 0.1 in this equation. So this will give you 1 plus 0.1 plus 0.1 square, plus 8 upon 3 factorial into 0.1 cube, plus 22 upon 4 factorial into 0.1 raised to 4. So this will give you 1.1114. Similarly, you can calculate y of 0.2, which is equal to 1.2521, and y of 0.3 equals to 1.4334. So these are the initial conditions which we require. So now as we have all this, we can calculate it by Pareto corrector method. So now what we have is x, y. So for x equals to 0, we have y equals to 1. For x equals to 0.1, we have 1.1114. For 0.2, we have 1.2521. And for 0.3, you have 1.4334. Similarly, you can calculate y dash as well. So y dash is equal to y square plus xy. So now after calculating this, you'll get 1.3463. That is this is your y0 dash, this is your y1 dash. So now next one is y2 dash. This will be equal to 1.8182, and third is y3 dash, which is equal to 2.4847. Now we know that the consecutive difference is 0.1, so h is equal to 0.1. Now by predictor's formula, we have yn plus 1 equals to yn minus 3 plus 4h upon 3 to yn minus 2 dash minus yn minus 1 dash plus 2yn dash. So from this, y4 is equal to y0 plus 4h upon 3 into 2y1 dash minus y2 dash plus 2 y3 dash. So substituting this value, you'll get 1 plus 4 upon 3 into h, which is 0.1, into 2 into y1 dash. We have calculated it as 1.3463 minus y2 dash is 1.8182 and 2 into y3 dash. So this will give you 2 into 2.4847. So after calculating this, you'll get 1.7792 as your answer. So now you have predicted one value. Now we have to correct it by corrector's formula. So by corrector's formula, you have yn plus 1 equals to yn minus 1 plus h upon 3 yn minus 1 dash plus 4 yn dash plus yn plus 1 dash, which is equal to, so y4 will be equal to y2 plus h upon 3 y2 dash plus 4 y3 dash plus y4 dash. So now we need to calculate y4 dash for this. So y4 dash will be equal to y square plus xy. So y4 square plus x4 into y4, which is equal to 3.8772. So now we need to substitute this value in this equation, and we have rest of them, that is y2 dash and y3 dash and y2. So y4 will be equal to 1.77324. So this is the required answer. See one more example. Here we have to find y of 0.8, and given condition is y dash equals to x minus y square, and y of 0 equals to 0, y of 0.2 equals to 0.02, y of 0.4 equals to 0.0795, and y of 0.6 is given as 0.1762. So these are the initial conditions. We need to find y of 0.8. So writing down values of x, y and y dash, which is given as x minus y square. We have x equals to 0. For x equals to 0, we have y equals to 0. For x equals to 0.2, we have 0.02. For x equals to 0.4, we have 0.0795, and for 0.6 we have 0.1762. So calculating y dash for each one of them, so you'll get y0 dash as 0, y1 dash as 0.1996, y2 dash as 0.0795, and y3 dash will be equal to 0.1762. Here this is x0, x1, x2 and x3. Now we know that the difference is 0.2, so h equals to 0.2. Now I will use the predictor's formula, which is yn plus 1 equals to yn minus 3 plus 4 upon 3h into 2 yn minus 2 dash minus yn minus 1 dash plus 2 yn dash. So for n equals to 3, y4 equals to y0 plus 4 h upon 3 into 2 y1 dash minus y2 dash plus 2 into y3 dash. So substituting all the values from this table, you can get y4 equals to 0.30488. Now this is the predicted for value. Now if you have to use corrector's formula, that is Cyn plus 1 equals to yn minus 1 plus h upon 3 yn minus 1 dash plus 4 plus yn plus 1 dash. So now this will give y4 equals to y2 plus h upon 3 y2 dash plus 4 y3 dash plus y4 dash. So this will give you y4 dash. You have to calculate. So this y4 dash is x4 dash x4 minus y4 square, which is equal to 0.7070. So substituting its value in this equation, you'll get y4 equals to 0.30458. So as we have seen before, that if you are not given initial conditions, then you can use Taylor series. Another method is you have to use Picard's method. So it is given in the question that you can use Picard's method to find the initial condition. So let's see what Picard's method is. It is not actually in your syllabus, but a question might be asked on that, so it's better if you know that. So now suppose if you are given any condition of ordinary differential equation, so suppose dy upon dx is given to you and it is some function in x and y, then initial condition, the first initial condition is given, that is x0 is given and corresponding y0 is also given. You have to find next initial conditions. So now let's take one example and then you'll get to know what it is. So suppose you are given a function dy upon dx equals to x minus y square. This is the given ODE or differential equation, and the initial condition is x equals to 0 and y equals to 1. So now we have to use Picard's method to find the value of other initial conditions. So as we can write, x0 equals to 0 and y0 equals to 1. Now f of x is given as f of x comma y is given as x minus y square. So by Picard's method, for yn plus 1, you need to find y0 plus integral x0 x y of x comma yn dx. This is your basic formula for Picard's method. Now how you can solve it? So first you need to find yn plus 1. That's the first approximation of that. So now for y you have to find y1, so n should be equal to 0, and this is your first approximation. So for y1 you have y0 as it is. Y0 is everywhere, it won't change in any of the approximation. X0 is same, x0 to x f of x comma y0 dx, because n equals to 0, so y0. So now y0 is nothing but 1. It is the first initial condition. X0 is 0, 0 to x f of x comma y0. So f of xy is nothing but it is given as x minus y square. So now you can substitute x comma y0. Y0 is nothing but 1. So you can directly write x minus 1 square dx. So that is nothing but 1 plus integral 0 to x minus 1 dx. Solving this, you'll get 1 plus x square upon 2 minus x, and the limits are from 0 to x, and this will give you, after substituting limits, you'll get the same thing. So it is 1 plus x square upon 2 minus x. So this is the first approximation, that is y1. Now you need to find y2. So for y2, again you have to use this formula. So y0 as it is plus integral x0 to x f of x comma, as it is y2, you have to make use of y1 dx. Now y1 we have already found it or calculated here, so you have to make use of it. So y0 is 1 plus integral 0 to x f of x comma y1. So this is x minus whatever y1 is square of that. So 1 plus x square upon 2 minus x whole square dx. So next, solving this, you will get 1 plus integral 0 to x naught is nothing, 0 to x, sorry, x naught not x, into x minus, now expanding the square, you'll get a square plus b square plus a square plus 2ab plus 2bc plus 2ac. So having that formula, it is x raised to 4 upon 4 plus x square plus 1 minus x cube minus 2x plus x square. So this is dx. So now it will become 1 plus integral 0 to x minus x raised to 4 upon 4 minus x square minus 1 plus x raised to 3 plus 2x minus x square dx. So integrating this, you'll directly get x square upon 2 minus x raised to 5 upon 20 minus x cube upon 3 minus x plus x raised to 4 upon 4 plus 2x square upon 2 minus x cube upon 3. And the limits are again from 0 to x. So no change in this. So it will be x square upon 2 minus x raised to 5 upon 20 minus x cube upon 3 minus x plus x raised to 4 upon 4 plus x square minus x cube. So now you got this entire, you can rearrange, and then final answer will be 1 plus 3x square upon 2 minus 2x cube upon 3 plus x raised to 4 upon 4 minus x raised to 5 upon 20 minus x. So this is the value for y2. Now if you observe, then you can again calculate y3, but in that you have to make use of this entire whatever value of y2 is, and to find the integration of it, it becomes quite complicated. So you have to stop where you feel that integration of that term is complicated. Then yeah, you have to make use of this y2 as your value of y. So finally you can make use of this y as y of x equals to 1 plus 3x square upon 2 minus 2x cube upon 3 plus x raised to 4 upon 4 minus x raised to 5 upon 20 minus x. Now you can substitute any values of x as you wish to find value of x. So as you know that x is given, x naught is given as 0, y naught is given as 1. So you can have x1 anything but x1, x2, x3, but keep in mind that the difference should be constant. So you can take 0 0.2, 0 0.3, 0 0.4 depending on the question what you have asked. So just keep in mind that you have to take minimum 4 steps. That means you have to find up to x4 or x5 or x6. So minimum you need to find value of y4 in the Milnes corrector formula.